So in this video I'll be going through some exam questions based around the topics of surds, indices, quadratics, discriminants, inequalities, algebraic fractions, and factor theorem. So if you look at this first question, now whenever you're dealing with any question you always want to try and identify what topic it is related to, because obviously that sometimes makes it easier, particularly when you've been revising like a mixture of topics. Now in some cases it'll be really obvious about which topic it's going to be, like for example this one here, we know straight away it's going to be surds, and so it's always important that, particularly when you're practicing through exam papers, is identifying what topic it is. Also, if you're making any mistakes, you can then go back and revise that topic, which again is a really good sort of technique to be doing when you're revising. So anyway, back to this question. So this question says, show that 5 root 2 plus 2 over 3 root 2 plus 4 can be expressed in the form of m plus n root 2, where m and n are integers. So for me, this question rings alarm bells. We know it's going to be surds, so it's either going to be simplifying or rationalising. Now this one, it's definitely going to be rationalising, as you can see, because the form that they are wanting is where we haven't got any fractions. So we're going to eliminate that fraction, particularly the denominator anyway. Now the other thing to make a note of is the fact that it gives you some key information that m and n are integers. So during this question, if you find that m and n are, let's say, decimal numbers or fractions, then you know you've definitely made a mistake somewhere, because like I said, they're supposed to be integers. Now the other key thing to note is this plus n. Now for this I'm not forwarding because I don't know what the answer to this question is just yet, but just because you've got m plus n root 2 doesn't mean that n is automatically going to be positive. So if you find out that during your working out, when you come to the end, you find that n is negative, then that's absolutely fine. So don't be sort of confused by when the format in which they're saying is a plus when you've worked out a minus, because all we know is that m and n are integers. So again, plus or minus doesn't make a difference, but as long as they're not decimals or fractions. So let's have a look at working through this question. So when we are rationalising the denominator, the key thing we'll need to do is to multiply both the denominator and the numerator by the denominator, reversing any signs that we may have. And it's always important that you're able to write this. Now this in itself will probably get you 1 mark, because obviously it's worth 3 marks, so 1 mark just by multiplying the fraction by the denominator, reversing any signs. Now obviously if I wrote plus there, I'm going to lose marks. If I decided to be a little bit cheeky and plug this into my calculator, because my calculator can work with surds, again I'm not going to get any marks for it, because they're expecting me to show how I get from one form to another. So once we've got it in this form, what we then need to do is start multiplying. So we've got 5 root 2 plus 2. I'm going to multiply that by 3 root 2 minus 4 over 3 root 2 plus 4, and we've got 3 root 2 minus 4. So working this out and multiplying both the top and the bottom, this is going to get a little bit messy. So again, the key thing to remember when we're multiplying surds, you can only multiply numbers outside the surd by itself and numbers inside by itself. So here I've got 5 root 2 times 3 root 2, which is 5 times 3, which is 15. Root 2 times root 2 is root 4. And then I've got 5 root 2 times minus 4, which is minus 20 root 2. Then I've got 2 times 3 root 2, which is positive 6 root 2. And then I've got 2 times minus 4, which is minus 8. Now looking at the bottom, I'm going to have 9 root 4 minus 12 root 2 plus 12 root 2 minus 16. Now when it comes to this, now this in itself will probably get you that 2nd mark. Now what we now need to do is to simplify where we can. So this bit here is 15 times 2, which is 30, so I can cancel that down and write that as 30. This is going to give me minus 14 root 2, and I've got minus 8. So looking at that numerator, that's going to be 22 minus 14 root 2, and that's my numerator. Then working with the denominator, 9 root 4 is same as 9 times 2, which is 18. The minus root 2, 12 root 2 and plus 12 root 2 cancel out, and I've got minus 16, and so my new denominator is just simply going to be 2. Now I still haven't, if I then write down what that equals, I've got 22 minus 14 root 2 over 2. Now the key thing I need to note is the fact that these are all multiples of 2. So I can cancel each of those down by and divide by 2. So that becomes a 1, that becomes 11, and that becomes 7, giving me a final answer of 11 minus 7 root 2. That now is in this form. So here, if I wanted to, I could write m equals 11 and n equals minus 7, and there is your final answer. And so somewhere from going from there would get you your third mark. So it's always important you set your clear working out and you can understand where it is. Now, with regards to exam markings, I'll just say this, I don't have to say this throughout the video, is that sometimes the amount of marks available for a question are either going to be worth how many steps you need to do or how long it should take you to do. So this question, I usually go through the process of a minute a mark. So although, as you can see, we've done a fair bit of work, it should really aim to take you about 3 minutes to do. So I won't say there's 3 particular sort of steps that we do, because as you can see, we've done quite a few steps, but it should take you around about 3 minutes to complete. So some questions will be very generous, some will be based on, or some questions I should say will be based on how much work you need to do to answer the question, and some questions might be how long it should take you to get to the answer, and obviously some key bits of information that are needed in your answer. So moving on to question 2, so again we are looking at surds, and this is broken up into a 8-mark question. So looking at AI, all we need to do is simplify root 18 and write it in the form of k root 2. So the key thing with regards to root 18, you want to think what square number goes into 18, which is 9, so we can write this as root 9 times root 2, which then becomes 3 root 2, where k equals 3. And again, one simple mark, job done. For question 2, again we're looking at simplifying. So here we've got root 8 over root 18 plus root 32. So again, you're going to deal with these separately. So root 8 is root 4 times root 2, which is 2 root 2. We've got root 18, which we've done previous in the other question, which is 3 root 2. And we've got root 32, which is root 16 times root 2, which is 4 root 2. So joining those 3 components up, I'll just put a little bubble around that. What that then becomes is root 8 can be written as 2 root 2 over 3 root 2 plus 4 root 2, which then becomes 2 root 2 over 7 root 2, and then we can cancel out our root 2's, just leaving us with 2 over 7. Now in terms of where the marks would probably be rewarded, you may get up to 2 marks for simplifying each of these. I'll say you probably just get 1. You'll get 1 mark for having 2 root 2 over 7 root 2 where you've not simplified it, and then 1 final mark for your final answer of 2 root 7. Now working on with B, again we are looking at rationalizing the denominator. So here we've got 7 root 2 minus root 3 over 2 root 2 minus root 3. So again, where you get your first mark is by multiplying both the top and the bottom by the denominator, turning the minus sign into a plus. So once we've got that, we then need to look at expanding. So let's just go for, I'll go for orange. So here we've got, and I'm just going to, not rather than going to double brackets, I'm just simply going to multiply them out. So I've got 7 root 2 times 2 root 2, which is 14 root 4, plus, and that's going to be 7 root 6, and then we've got minus 2 root 6, and then we've got minus root 9, and that's all going to be over 4 root 4 plus 2 root 6 minus 2 root 6, minus root 9. And again, one thing you definitely don't want to do is start cancelling both the top and the bottom. We want to simplify both the top and the bottom first. Now 14 root 4 is the equivalent of 14 times 2, which is just 28. 7 root 6 minus 2 root 6 is positive 5 root 6, and I've got a minus 3. So the numerator of this is going to be 25 plus 5 root 6. And then looking at the bottom of the denominator, say we've got 4 times 2, which is 8. We've got 3, and I cancel those down, which cancel out. So I've got 8 minus 3, which is 5. And then from this, I can then cancel this down because I can divide both the terms by 5. So that becomes 5, that becomes 1, that becomes 1, leaving me with a final answer of 5 plus root 6. And again, if I want to convert it in terms of what the integers are, m equals 5 and n equals 6. So where the 4 marks for this particular question will come from, so let's use a colour I've not used. Let's go for black, or let's go for red. Let's change one of these. Come along. Right, so you get 1 mark for multiplying both the numerator and denominator, 1 mark for expanding out the brackets, 1 mark for having 25 plus 5 root 6 over 5, and then 1 mark for your final answer of 5 plus root 6, giving you a total set of marks of 8 marks. Now the next thing we move on to is question 3. Now again here we're looking at indices. So again, it's always good. You don't need to write this in your exam. This is if it's a practice paper or whatever, then that's usually useful. But again, it's just something to think about when you get stuck on a question. Try and think about what topic it relates to, and then just think about what you revised from that topic. So if you look at AI, so it says write down the values of P and the value of Q given that. So we've got root 3 equals 3 root P, 3 to the power 3. Now again, using this, we know that that's going to be equal to 3. We can rewrite root 3 as 3 to the half. So therefore, P is going to equal a half for 1 mark. For part 2, we've got 1 over 9 equals 3q. Now all you want to do at this is just deal with one side. So I'm just going to deal with 1 over 9. So take the more complicated sign. I can write 1 over 9 as 1 over square of 3, and then I can rewrite this as 3 to the power of minus 2. So therefore q equals minus 2 for your second mark. So moving on to question B, we can see that we have already done some other components. So ideally when you're dealing with these types of questions, you want to try and get the base numbers the same. So root 3 I can write, so if I just start by writing the question out again, it might be easier. Like so. And we want to find the values of x. So we know that part root 3 can be written as 3 to the power of a half. 3x is something that I can't do at the moment, and I can, using AII, we can write 1/9 as 3 to the power of minus 2. Now because our base numbers are the same, and when we are multiplying we're adding the powers, so what I've got is I've got a half plus x equals minus 2. So x then equals minus 2 minus a half, which then equals minus 2.5. So x equals 5 over 2. And I would say you can either leave it as 5 over 2 or, minus 5 over 2 it should be rather, or minus 2.5, just because it's terminating decimal. But personally, I would always go for leave it as a fraction. So with question 4, it says that a rectangular garden is to have a width of x meters and a length of x plus 4 meters. And question A says the perimeter of the garden needs to be greater than 30 meters. Show that 2x is greater than 11. So to help you with this question, sometimes it might be easier to do a little sketch. So if we draw a rectangle, and we know that the length is x and x plus 4. So working out the perimeter of this, then that's going to be x plus 4 plus x plus 4, and that needs to be greater than 30. Now if I simplify this, I'm going to get 4x plus 8 equals 30. Actually, I need to put the inequality signs, let's not forget that. Is greater than 30. I've got 4x, so I take the 8 over to the side, which gives me 22. Simplify that to give me 2x is greater than 11, and QED, because I've proven what they've wanted me to prove. Now for B, it's saying that the area of the garden needs to be less than 96 meters. So here the area of that rectangle is going to be x, and then x plus 4, and that needs to be less than 96. So then expanding the brackets out, I've got x squared plus 4x is greater than 96, and then because they want it in this sort of format, all I've got to simply do is take the 96 over, so I've got 96 plus 4x minus 96 is less than 0. And again, each of these questions are worth 1 mark, so it should take you about a minute to do. But it is always important that you do still set your work out. Like for example, it's to show that question is only worth 1 mark, so you're not going to get a mark just for writing 2x is greater than 11. You have to show the steps in which you've derived that particular conclusion. And then for part C, what we then need to do is to solve the inequality. And I'm going to do the C over here, so let me just get rid of that there. Now this is worth 4 marks, so it's important that you look at the 4 steps needed for this. So what I'm going to do is I'm going to start off by writing the inequality, and then as it looks like a quadratic, I then need to think to factorise it. So it does factorise, in which it's going to give me 8 and 12. So I've got 8 and 12. Now because I've got a plus, it means that the 12 is going to be positive, the 8 is going to be negative. Now this is where you'd get your 1 mark, is for writing that line where you factorised it and you've used the inequality. If you've wrote equals, there's a chance that you might lose a mark for that. And then finally for this, we've got our 2 solutions of x is going to be 8 or x is going to be minus 12. Now from this, which is so we get 1 mark for solving that quadratic. Now at this stage, if you wrote equals 0, they'd probably allow it for this stage, because again the actual question's asking us to solve the inequality. Now this is where a lot of students tend to go wrong. Now here, if I draw a sketch, which is basically what they're looking for, I know the roots of this quadratic are at minus 12 and it's at 8. And this parabola is going to go through those 2 points, like so. Now I want the values of where it's less than 0, so I'm wanting this region here. So then the answer to solving this equality is going to be minus 12 is less than x is less than 8, and there is your final answer. Now again, you'll lose a mark if you don't draw a sketch, and obviously you've got your 4th mark coming from your final answer. And then the final question then says, hence determine the possible values of the width of the garden. Well, x can either be minus 12 or between a region of minus 12 to positive 8. Now for here, we're looking at the width of the garden, which is x. So here I'm going to be looking for a width of 5.5 to 8. Now the reason behind this, if I just label this as D as the answer and just put it here, is because for starters the width of the garden x needs to be positive, so that then gives me a range of 0 to 8. Now the problem with this is the fact that it still needs to satisfy these 2 conditions, that 2x needs to be greater than 11. So obviously I'm looking for values of where that's going to be the case. So if x equals 1, then 2 times 1 is not going to be greater than 11. So we need to use this 2x is greater than 11 to get this answer here. It's a bit of a sneaky question, and again, more commonly students would write 0x to 8, knowing the fact that the answer's got to be, x has got to be positive because you can't have negative length. But this is the part that we need to look at, and again we need to write it as an inequality because there are several lengths that it could be. So for question 5, the first one refers to completing a square, so let's just put that in brackets. So we want to try and express 2x squared minus 5x plus k in the form of a bracket x minus b squared plus c. So to start this off, what we need to do is just quickly write down the question. is, first things first, is factorise with respect to 2, because we want to try and get x squared by itself. So what I'm going to do is just divide everything else by 2, and I get that. Now the constant doesn't need to be done in this way, but I'm going to include it because usually we include everything. But if I wanted to, I could have just easily just factorised with respect to the first 2. Get rid of that plus. Minus 5 over 2x, and then left the k completely separate. But again, that if you've done it that way, that will be absolutely fine. But I'm just going to include it. And then what we then need to do is apply completing a square on these two. So I've got the 2, I'll leave that out. So I've got x, and I'm going to halve this again, so it becomes 5 over 4 squared plus k over 2, and I'm going to subtract 25 over 16. And then from this, what I'm then going to do is multiply everything out by 2. And to that, well, there's only one bracket that's needed there, so let's just get rid of that. And then in which what I've got is I've got 2x minus 5 over 4 squared plus k minus 25 over 8. And there is the expressed value. And for b, what we then need to do, now there's several ways in which we could do this. We can do a method that involves comparing the minimum point or the vertex of the parabola and showing that it can't equal 3. But I would say whenever it comes to intersect, we always want to think of simultaneous equations. So first things first, let's make the two equations equal to each other. It's equal to 3. Now we don't want the two lines to intersect, so well, let's first things first, as it's looking like a quadratic, let's chuck everything all onto one side. So I've got 2x squared minus 5x plus k minus 3 equals 0. Now because we don't want them to intersect, basically what that means is that we want no roots. And if we want no roots, that means then that b squared minus 4ac has got to be less than 0. So looking at this, we've got a equals 2, b equals minus 5, and c equals k minus 3. So using that notion of having no roots, and b squared minus 4ac is less than 0, which is worth writing down at this stage, then we could then substitute the numbers in. So we've got minus 5 squared minus, and then close square brackets, 4 times 2 times k minus 3, close bracket, and again that's less than 0. Making sure that we always include the less than 0 because obviously it's part of the actual proof. So what we get is 25 minus, and then close bracket, 8k minus 3 is less than 0. Taking that out again, we've got 25 minus, and then if I, well, let's expand the brackets first. I've got 8k minus 24, and then if I just move over here, so I've just got a bit more space. And then what I've got is I've got 25 minus 8k plus 24 is less than 0, and then if I simplify this, I get 49 minus 8k is less than 0. Take the 8k over to the other side, so I've got 49 is less than 8k, and then 49 over 8 is less than k, or k is greater than 49 over 8. So for the line not to intersect, k needs to be a value that is bigger than 49 over 8. So moving on to question 6, we have a factor theorem question. So let's just quickly write down this is a factor theorem stroke polynomial question. So the first thing we want to do is use the factor theorem to prove that x plus 3 is a factor of p, the function p of x. Now for this, it's really important in terms of layout, which a lot of students will lose some silly marks on. So the first thing to do to start off with this question is state that if x plus 3 is a factor, then p of minus 3 is going to equal 0. So then from this, what we then need to do is substitute minus 3 into our function. So we've got 2 minus 3 cubed plus 7 minus 3 squared plus 2 times minus 3 minus 3, and that does in fact equal 0, so therefore x plus 3 is a factor. Now again, it's really important that you state all of those to get the 2 marks, particularly this last point. So you get 1 mark for basically stating one of these two and showing that you've substituted the value in, and then your final mark comes from actually stating that therefore x plus 3 is a factor. Now moving on to B, what first we need to do is we need to think about factorise. The question's asking for us to simplify the expression. Now most students when they see a question in this form automatically think that it's going to be an algebraic long division, usually because that's somehow how the question is started. I'm just going to emphasise the fact that those two things are pluses. So working through this, now we already found that x plus 3 is a factor, so the first thing we then need to do is to factorise fully the function of p of x. So I've got x plus 3, and then I'm going to do the algebraic way. So you could do algebraic long division to factorise it, but again it's probably easier and quicker to do the algebraic expansion method to do that. So here we've got ax cubed plus bx squared plus cx, and then we're going to have 3ax squared plus 3bx plus 3c, and if I add that all up, which I'm going to do here, I'm going to get ax cubed plus bracket b plus 3a x squared plus c plus 3b x plus 3c. Now what I'm then going to do is compare that to the original equations. Let's use green. So our original function was 2x cubed plus 7x squared plus 2x minus 3. Now if I compare the coefficients, I can see that a is going to equal 2. I know that b plus 3a is going to equal 7. Well, if I know that a equals 2, I've got b plus 3a, 3 times 2 equals 7, so b equals 1. And if I know that 3c equals minus 3, then c is going to equal minus 1. So from this, I've got the equation of, now factorising the denominator, well I should notice that this is a difference of 2 squares, so that's going to be 2x, 2x, 1 and a 1, 1's a plus, 1's a minus. So from this we've got our expression. So first of all, let's just finish factorising the numerator. So I've got x plus 3, and then I'm going to end up with 2x squared plus x minus 1, and if I factorise that I get 2x plus 1 and x minus, actually 2x minus 1 rather, minus 1 and x plus 1. So from this, now if I just highlight what I'm going to be using, so factorising our algebraic fraction, I'm going to have this as my new numerator and this as my denominator. So then what I've got is I've then got x plus 3, I've got a bracket there, x plus 3, 2x minus 1, x plus 1, all over 2x plus 1, 2x minus 1. And from this I should be able to spot that I can cancel 2 of those brackets. It's giving me a final answer of x plus 3, x plus 1 over 2x plus 1. Now if you then go on to expand the top, in which if you did expand it you'd get x squared plus 4x plus 3 over 2x plus 1, then that's absolutely fine. Now a key area where a lot of students tend to go wrong is that because this is a fraction, that the number that you can't divide by with fractions is dividing by minus 1. So this algebraic fraction is going to be applicable so when x is not equal to minus a half. And it's really, really important. Again, a lot of students tend to forget this part. Don't know where the end's gone. Let's just put that back. There we go. It is this statement here. So whenever you've got an algebraic fraction, you want to try and find the value that makes the denominator equal 0. So how I've got that minus a half, I'm going to get a space here. So I've got 2x plus 1. So if whatever your denominator is, make that equal to 0. Solve it for x, so x equals minus a half. And then state that x cannot equal that value because obviously you can't have a denominator where it's equal to 0. And if you're not sure why, there are plenty of videos that will explain it. So as always, it's always good practice for you to state what topic this question refers to. So this is referring to discriminants and sketching quadratics. Right, so reading the question, it says curve C has the equation y equals x squared minus 6x plus k, where k is a constant. The equation x squared minus 6x plus k equals 0 has two distinct roots. Now, the key thing, the question is asking us to sketch part C. Now, the key thing with regards to this is knowing the sign of x squared, because we know it's quadratic, so we just got to decide whether it's positive or negative, and the fact that it's got two distinct roots. So the x squared means it's going to be a U shape, and this means it's going to cross the x-axis twice. So the only thing I've got to decide is when I draw my sketch is the U shape going to be more on the left side? Is it going to be straight down the middle? Or is it going to be on the right hand side? And as you can see from my sketch, that each parabola crosses the x-axis at two distinct points. So the question is how do I go about finding that out? Now, unfortunately, I can't work it out accurately because I don't know the value of k, but one thing I can do is if we look at figuring out where the minimum point is going to be. So if you use completing the square to do this, so we've got x minus 3 squared plus k minus 9. So what this tells me is that the x-ordinate of the coordinate of my minimum point, so the minimum point, and the reason why it's minimum point is because it's a U shape or a positive parabola, is going to be at 3 and then it's k minus 9. So from this, now doing my sketch, I know that the x-ordinate of the minimum point is on x equals 3, so that's my x equals 3 line. And what I'm going to do is I'm going to draw my parabola, making sure that the bottom bit hits at 3. Now from this, I know that because it's a U shape and it's got two distinct points, that the y-intercept is going to be a positive value. So k is going to be on this side. And labelling my axes, this is what I get. So that will get me full marks in for the 2 marks in this particular question. So you get 1 mark for the U shape and 1 mark for having the U shape in the correct position on the right hand side of the axes. Now the next question then says is find the possible range of values for k, fully justifying your answer. Now the key thing with regards to part B, and if I just do this over here, is again knowing that it's got two distinct roots. So as it has two distinct roots, I know that b squared minus 4ac is going to be greater than 0. So if I take the equation x squared minus 6x plus k is greater than 0, I know that, well actually I shouldn't write greater than 0, is equal to 0. What am I going to go for here? That's it. I know that a is going to equal 1, b is going to equal minus 6, and c is going to equal k. So from this, what I can then do is substitute this into my discriminant. So I've got minus 6 squared plus 4 times 1 times k, and that's going to be greater than 0. So simplifying this out, I get 36, and it should be a plus. Don't know where that plus has come from. So let's just get rid of that. Minus 4k is greater than 0, and solving this we get 36 is greater than 4k, and so 9 is greater than k, or k is less than 9. Now the key thing is where a lot of students would probably leave the answer is leaving it as this. However, if we go back to our sketch, we know that k has got to be on the have a positive y value. So although k, we've been said by working this inequality, states that it's less than 9, we know that it's got to stay positive. So the actual final answer of how we need to write this is that k has got to be a value between 0 and 9, and that there is our final answer.